Hello users, welcome to my YouTube channel. This is a documentation that I made about a project which I worked on. Um, the project basically consists of different ESP8266 functions, and to remind you, this video is going to talk about the robust features of the ESP8266. So at first, let's look at the libraries I included. This is the Wi-Fi library, which enables us to use the Wi-Fi, the Arduino Research user interface, which is used to generate random bytes, the multicast DNS library, the hash library, little fs for little fs, web server for web server, then HTTP update server, which is used for which is used to update the ESP8266 board with a new firmware. Then we have the WebSockets library. These are definitions for some times. Instantiations for the IP address, ESP82 web server, our server, the ports it is going to connect to, then our WebSocket, then its port also, our constants also. Then we have these five functions which I used to start using this library above. We have the start MDNS, which is used to initiate the multicast DNS communication. We have the Wi-Fi, which is used to start the Wi-Fi and connect to an access point. We have the little fs, which is used to start the little fs flash system on the microcontroller. We have the web server for web server, then we have the WebSocket for communication. We have this handle root function, which is used to handle the root on the web server. We have the upload not found, home post, file upload, verification, HTML read. We have the WebSockets function. We have these functions also check auth, which is like check authentication. We have the set cookie, which is used to set cookie to the client. Set hue, which is used to make a rainbow output to our RGB LED. We have this check line, which is used to iterate through the cookie file to count the number of lines in it. We have the generate secure token, which is used to generate the 64-byte cookie, which is used as the cookie which is served to the client for verification. We have this format bytes get content type, which is used to get the MIME type of our file, then compare cookie function. Without wasting much of our time, let's go into it. So here we start the Wi-Fi. As I told you earlier, this video is not to teach you how to use all these functions, because if I'm going to do so, this won't be enough. So basically I'm just going to give you, like I said, this is just a documentation. So I'm just trying to write down and make a video on what I did. So if you can copy it, go read it, understand it, and then make use of it and modify it as you wish. This is my code, basically a 900 plus lines of code for my robust and awesome web server. Let's go to our browser. As I told you, this this code has multicast domain name service, which allows us to connect to the ESP web server without using the IP address. Like, it has a static DNS which you can use to connect to without changing the IP address all the time. We are going to use this window as our output debug output. So I'm going to pair it with the sorry I'm going to pair this with our debug output. So as you can see, this is our browser and this is our debug output. Let's get into it. Now I'm going to search esp It gave us the index file. As you can see, this is the index file. So if I refresh it now, there is no cookie to the client. So if I refresh the board like this, see our debug output, it gave us some content here. Let me see. Communication started, then it lists all of the files inside the little fs. So this is my file data. This is our file on the little fs. Each file has its own function. It has what to serve. This is our secure folder, although it's not secured. I just named it secure because it's somehow confidential. This is used to store the cookies which are sent to the client. This is used to store the Wi-Fi credentials that the ESP is going to connect to. And this is our files. So it lists the files. Attempting to connect, it opened that folder which I already uploaded to the little fs. So it opened the folder, get the SSID, the password, and then it connected to this network right here. And I'm also connected to the network. You see, I'm also connected to it. So this is basically like an intranet communication. It's not an internet communication. It is a local communication. This is the IP address of the ESP microcontroller. So right now I'm going to sign in. So I'm going to try signing in with this given information below. So sign in, log in. It gave us the homepage. So you guys see the URI changed homepage. This is our debug output. First we were here already, then it came to inside homepage post, sorry. That is, it is going to give us this homepage. It set the cookie, checking cookie. This is our cookie right here. If I can check, let's. This is our cookie right here. It was served to the client. The client collected the cookie. Where is it? Network reload. Yeah, the client collected the cookie. You see, cookie. This is our cookie, the name of the cookie, and this is the value for the cookie. So here it is. So basically what happens here is that the code, this code, this one right here, where is it? Yeah, this one. This code, it sets the cookie. It goes into a function, sets the cookie, serve it to the client, and then the client, whenever it tries to access any URI, any of the 6 URI, then if it tries to access the URIs, the server is going to authenticate the user verification using this cookie. It is a 64 bytes long cookie. So basically for this it's a good secured cookie. So these are the features of this web server. Firmware updates, which we can update the firmware which the ESP8266 is running on. We can upload a new file, update credentials, control LED with WebSockets. You can see WebSockets, sorry, WebSockets, control LED through WebSockets without refreshing pages. We can view file using WebSockets also. So this is the page for the firmware update. See, the debug output changed also because we accessed another URI. So it authenticated again, and firmware update here, firmware update here also. It authenticated for the cookie. See it here. We served the cookie. It authenticated. The authentication was correct. It was true. Then it gave us the cookie. Assuming this cookie was not served to the client, or the cookie is not valid in the little fs, this web page wouldn't have been served to us. The resource for the page wouldn't have been served to us. So right now I'm going to input the password for my firmware update. ESP8266 at k underscore o. Yep, correct. So I'm going to choose a binary file. You see, binary file. So where is it? Yeah, here, build, yeah. It's only accepts binary file, unless, even if you change this to all files, the server wouldn't collect that file because it's not a binary. It's going to give an abort response. It is going to give an invalid response. So open, then upload. So you see, the upload is going well. It is loading here. As soon as it finished, it is going to redirect us. Yes, it redirected us to this page, the success page, which means our firmware update was successful. See, verification for firmware updates. Verification is good. Firmware update is done successfully. Everything is good. Now I can basically just press the reset button on my ESP board, and we are going to debug. We are going to run a new fresh firmware. So right now I'm going to just basically click the reset button. Clicked. You see, we have clicked the reset button. It lists the files again. it is trying to connect to my Wi-Fi. It connected. So where is it? This line. This is an updated firmware. I included it here for the new firmware update. Let's check for the old firmware. See, the line did not exist. It wasn't existing until after I updated the code. I generated the binary file for it, and then I uploaded it to this through this. So now if I refresh, it is going to take us back to the index page, the root page, because the cookie file has been erased. You see, cookie file has been erased. So basically, there is no cookie on the server, but there is cookie for the client. But even if the client passes it to the server is going to authenticate false because it doesn't have that cookie stored in it. So refresh, continue. See, back to the root page. So we are going to enter again. What I showed you was firmware updates which was successful. So let's go into file upload. Let's upload whatever file we want. Yeah, let me just upload this random.txt. Upload. Upload was successful. What is the name of the file we uploaded? Random.txt. Again, wait. Here, from all these files, random.txt did not exist. So now, if I reset the board again, and when the little fs is trying to list the files stored in it, it's going to include the random file again. So let me reset it. Reset. So where is it? See, random.txt, which did not exist before I uploaded it using here. Again, we are going, if we refresh, we are going back to that index. Wait, let me not even refresh. Let's just go back. Go back, try to access a new URI which we haven't accessed before. Access, see, it's, we went back to the index page because the client gave its cookie, but inside the little fs the cookie was not found. So we cannot compare the client's cookie with nothing, so the validation is false. So it redirected us to the index page. So sign it again, paste, login. Yeah, so basically you've seen the functions of these two URIs. Then this upload update Wi-Fi credentials. We are here, if we fill this with new information, it changes the internet, the access point which the board connects to next time. So here we're going to type the SSID, which I'm not going to do it now because I'm not trying to connect to another internet right now. So just forget it for now, but it's working. The new password, and then verified device password. That is the device, the password that the device recognizes as the password to be used to update the Wi-Fi credentials. This is crucial because it is used to avoid some unnecessary password changing, like someone to just access the URI and change the SSID and password without you knowing. So this is very very important. So for our control LED page, see, all of our debug outputs are going correctly. So because we connected this page, this page has it has WebSocket communication. So when we access the page, it gave us here, right here, the WebSocket function gave us that connection information, which it gave us, like, let me check, it gave us the IP address of the person that connected to our WebSocket, and the time the person connected to the WebSocket, which is here, the time and date. So now if I try to press this, the LED, which is basically at the bottom here, right bottom of my screen, if I press it, it's going to turn on. So watch, it turned on, off, green, on, off, blue, on, off, then rainbow is on. You see, rainbow is on. It's circulating through the rainbow colors on its own using the set hue function right here. Yeah, you see, it's some mathematical function. Yeah, so this is the control LED page. That's what it basically does. Then our last page, our last URI, which is the v file page. Here we are it is used to view txt files, text files from the little fs. We are going to view it on this web page, on this URI. So before, yeah, let's try to read that random.txt get file. This is the content of the file. You see, the user tried to access random.txt here, file to be sent to random.txt. The little fs, it checked its storage, it found the file, and it streamed the file to us. So if you check here, the file also is going to be the same, random.txt. You see, random. So it is the same. There's nothing different from it. And I can try to access this file here also, that it tells us to try. Yeah, you see, this is the content of that file also, which is inside the little fs. So basically, these 5 functions, these are the functions of my web server. I can use it to update firmware, upload file, update Wi-Fi credentials, control LED, view file. With this update firmware, I can do many functions as I want. Like if I make a product and it can't be accessed like serially, I can't connect it to my laptop because it's enclosed in a package. So that is when this update firmware function comes in play. It just accepts the binary, write it inside the second OTA partition of the little fs, sorry, the flash system, and then the next time the board flashes, the next time the board is turned on and off, it directly swaps to this new firmware. This upload file function too, it works just like that. This update credentials is also crucial because I already told you it's used to change the credentials of the Wi-Fi the board is going to connect to next time. And then I think that's all for this web page. So don't forget to check my uh, Medium page, because I did a well detailed documented article on this web page. If you're if you're more if you're more interested in this, yeah, you should check it out. Should try it. Try to understand what I did here, because this function, this web server, it's a good, robust, awesome web server. And you can check my GitHub page on the description below. You can check it to view the code and the files. You can download it and try it yourself. Don't forget to subscribe. Alright, goodbye. See you next time.